Welcome, my dear students. Today we are having the class on transformations. Three very important star marked problems we are going to discuss. On part of that, we have if first problem, if A sin x is equal to B sin of x plus 2 pi by 3, that equal to C sin of x plus 4 pi by 3. Prove that AB plus BC plus CA is equal to 0, right? My dear students, how we are going to do this particular problem, right, my dear students? Okay, wonderful. See this they have given that this A sin x is equal to B sin of x plus 2 pi by 3, right? And that is equal to C sin of x plus 4 pi by 3, right? That is equal to, you take, they are all equal, that's why you take that value equal to some lambda, right? Wonderful. Now you see, my dear students, what we are having is from that we can do that something like sin x is equal to lambda by a, right? A sin x equal to lambda means sin x is equal to lambda by a, and b sin of x plus 2 pi by 3, that equal to lambda means sin of x plus 2 pi by 3, that is equal to lambda by b, right? And C sin of x plus 4 pi by 3 equal to lambda means sin of x plus 4 pi by 3. Sin of x plus 4 pi by 3 is equal to lambda by C, right? These are the three things we have got now. What we do, my dear students, after getting them, let us take lambda by A plus lambda by B plus lambda by C, like this. If you take lambda by A plus lambda by B plus lambda by C, right? My dear students, what we are going to get, that is sin x plus sin of x plus 2 pi by 3, right? Plus sin of x plus 4 pi by 3, like sin of x plus 4 pi by 3, like this, right? Wonderful. Once we have got the things like this, what we do is, let us try to group the things like sin of x plus 4 pi by 3 plus sin x plus sin of x plus 2 pi by 3 plus sin of x plus 2 pi by 3, like this, right? Wonderful. This is nothing but lambda. If I take common here, this is now, however, right? Fine. Let us take LCM of course, right? If you take LCM as ABC, then what we are going to get, lambda times of BC, this one, plus lambda times of AC plus lambda times of right, AB we are going to get, my dear students, right? Where ABC is what? The LCM here. Wonderful. Now let us apply sin C plus sin D formula here. Once if you apply sin C plus sin D formula here, like this, this is what ABC, yeah. 2 sin C plus D by 2, 2 sin C plus D by 2, x plus x, 2x plus 4 pi by 3, that is nothing but sin of x plus 2 pi by 3, right? Because 2 sin 2x plus 4 pi by 3 by 2, that is nothing but 2x by 2 is x, 4 pi by 3 by 2 is nothing but 2 pi by 3. Okay, 2 sin C plus D by 2 cos C minus D by 2. Okay, wonderful. X plus 4 pi by 3 minus x by 2, that is nothing but 4 pi by 3 by 2, that is now 2 pi by 3. We have like this, wonderful, right? Okay, fine. Now this is equal to plus sin of x plus 2 pi by 3, right? Wonderful. Now cos 2 pi by 3, that is cos 120. Cos 120 degrees is nothing but cos 180 minus 60, that is minus cos 60, that is minus 1 by 2. Therefore this becomes 2 sin x plus 2 pi by 3 into minus 1 by 2 plus sin of x plus 2 pi by 3, right? This, now these two will cancel. Now minus sin of x plus 2 pi by 3 plus sin of x plus 2 pi by 3, that equal to 0, like this, right? That means what you see, my dear students, we have got lambda. If you take common here, let us write perfectly AB plus BC plus CA by ABC. This is equal to, right? Okay, my dear students, you see just here, lambda times of AB plus BC plus CA by ABC is equal to 0. From that, let us okay, subject AB plus BC plus CA, AB plus BC plus CA, that is equal to 0 into ABC, 0 into ABC by lambda. that is nothing but 0. Therefore, we have got here AB plus BC plus CA is equal to 0. See, such a wonderful and very important problem. You are having these type of problems, even you are having in your material also. My dear students, you have to do this very carefully. It's a very simple technique what we have followed. Right, my dear students? Now we have another beautiful problem. This is second one. If sine of x plus alpha by cos of x minus alpha is equal to 1 minus m by 1 plus m. Prove that tan pi by 4 minus x into tan pi by 4 minus alpha is equal to m, like this. Right? Fine. Now you see here, we have this thing like 1 minus m by 1 plus m. 1 minus m by 1 plus m is equal to sine of x plus alpha by cos of x minus alpha, like this. Right, my dear students? You know that componendo dividendo method. Let us apply componendo dividendo method. A by b by c by d is equal to a by b by, right, c by d. That implies, you know, that a plus b by a minus b is equal to c plus d by c minus d. Right? Once you apply this componendo dividendo method, you have here 1 minus m plus 1 plus m. Whole thing divided by 1 minus m minus 1 minus m, like this. This is equal to sine x plus alpha plus cos x minus alpha, right? Because this is something like a plus b by a minus b, and this is now sine x plus alpha minus cos of x minus alpha, like this, right? Fine. This is now minus m plus m will cancel, 1 minus 1 will cancel. Now this is 2 by minus 2m, like this. This is equal to, we have, my dear student, now I want to apply sin z plus sin d formula, but I am having here sin and here cos. I want to transform any one of them into, right, sin. That's why what I do is, sin x plus alpha I am having here, this cos I will try to convert into sine. That means how I will use is, so this is nothing but sine pi by 2 minus, okay, sine 90 minus theta. Only you will be getting here sine pi by 2 minus x minus alpha, like this. Whole thing divided by, here also you are having here sine of x plus alpha minus sine pi by 2 minus of x minus alpha, like this, right? Wonderful. Now we have got the thing like this. 2 will cancel. Now this is minus 1 by m is equal to sin c plus sin d, like this. Right? Sin c plus sin d. This is now sin c plus sin d is what? 2 sin c plus d by 2 cos c minus d by 2. Therefore, this is 2 sin c plus d by 2 x plus alpha, right, plus pi by 2 minus x, 2 sin c plus d by 2, pi by 2 minus x plus alpha whole by 2, 2 sin c plus d by 2 cos c minus d by 2. This is now cos c minus d by 2, x plus alpha minus pi by 2, right, plus x minus alpha whole by 2, like this. We have got. Wonderful. Right? Fine. Now you see, my dear students, just what we did is we just applied the formula sin c plus sin d. This is nothing but c plus d by 2, c minus d by 2, x plus alpha, okay, x plus c minus minus pi by 2 plus x minus alpha by 2, right? This whole thing divided by, right, we have here sin c minus sin d, that is nothing but 2 cos c plus d by 2. That is what, x plus alpha plus pi by 2 minus of x minus alpha by 2. 2 cos c plus d by 2 sin c minus d by 2, like this, sin c minus d by 2. That means x plus alpha, okay, c minus d. Minus d means what? No? You are going to get minus pi by 2 plus of x minus alpha, this whole by 2. This is what we are going to. If we just simplify, we will be nearer to our problem. Just observe what we did is sin c plus sin d is 2 sin c plus d by 2 cos c minus d by 2. Sin c minus sin d is 2 cos c plus d by 2 sin c minus d by 2. Right, my dear students? Once very good, we have got this thing. This if we simplify, what we are going to get, right? You see, my dear students, what we are going to get is minus x plus x will be cancelled like this, and alpha plus alpha, this is what we are going to have here. I am just writing here. You see, my dear students, this is equal to minus 1 by m into 2 sine, right? This here, however, 2 and 2 we can cancel here. This 2 we can cancel. This is what we have got, sine of alpha plus alpha, 2 alpha plus pi by 2 by 2. That is nothing but alpha plus pi by 4. Wonderful. Alpha plus pi by 4 or pi by 4 plus alpha. And here, what will be cancelled? Plus alpha minus alpha will be cancelled. Right? That becomes x plus x, 2x. 2x minus pi by 2 by 2. That is nothing but cos x minus pi by 4 like this. Cos x minus pi by 4. This whole thing divided by like this. What we are having is cos of. Okay, here also you see, my dear students, what we do is this is minus x plus alpha. X minus x will cancel. Alpha plus alpha, 2 alpha. That is nothing but pi by 4 plus alpha. This is what, pi by 4 plus alpha, or alpha plus pi by 4. And into sine of what you have here like this. Here minus alpha plus alpha will cancel, x plus x. That is nothing but x minus pi by 4 you are having like this. Wonderful. Now this is equal to minus 1 by m into, right, sine by cos. That is nothing but tan of, right, what we have here like. Find tan of alpha plus pi by 4 like, or pi by 4 plus alpha. Tan pi by 4 plus alpha we are having here nicely. Right? Once we have this one, and this is now actually cot of x minus pi by 4. Right? Fine. Tan pi by 4, right, plus alpha. Now see, my dear students, this is equal to, okay, 1 by m, we will take minus. Let us take that to that side, then it becomes tan pi by 4 plus alpha, right? And this is now cot of pi by 4 minus x, because this minus sign we are taking inside of this. This becomes minus x plus pi by 4. Now m is equal to, what you will be having is, you take the reciprocal. Once you take the reciprocal, it becomes tan pi by 4 minus x, right? And cot pi by 4 plus alpha. Because we have taken the reciprocal. This is 1 by m. 1 by m means just take the reciprocals, ulta, like, okay. Once we got this, now m is equal to tan pi by 4 minus x. Tan pi by 4 minus x into cot. This cot we can write it as tan pi by 2, right? This we can write it as pi by 2 minus of pi by 4 plus alpha like this. Now this is equal to, m is equal to tan pi by 4 minus x into, right, fine. This is actually cot 90 minus theta. That become, now we have got tan, what we will get? Okay, pi by 4 minus alpha, right? You see, my dear students, here some small logic here. This cot only we have converted into tan like this. Tan pi by 2 minus pi by 4. That is nothing but pi by 4 minus alpha like this. See how beautifully we have got this problem. M is equal to, only simple technique we applied, componendo dividendo method, and applied sin c minus cos is there, we converted into sine, okay, by applying okay, sin pi by 2 minus theta, okay, and we just did our process by applying sin c plus sin d, sin c minus sin d, and we have got beautifully this result. M is equal to tan pi by 4 minus x into tan pi by 4 minus alpha. Very simple problems, right? See, my dear students, next we have one more beautiful problem. That is, if sine of y plus z minus x, comma, sine of z plus x minus y, comma, sine of x plus y minus z are in arithmetic progression. Prove that tan x, tan y, tan z are in arithmetic progression. See, my dear students, how we will do this particular problem, right? They given that these are in arithmetic progression. That means you know that second term minus first term is equal to the third term minus second term. That means we have here now sine of z plus x minus y. There. Okay, this is what? Second term minus first term, that is equal to sine of y plus z minus x, right? This is equal to, now we have here sine of x plus y minus z minus sine of z plus x minus y, like this, right? Wonderful. Now very simple, my dear student, this is what actually second term minus first term is equal to the third term minus second term, what we have got here, like this. Now, sin C minus sin D, if you apply sin C minus sin D formula here, like, right, once you apply sin C minus, that is nothing but 2 cos C plus D by 2. 2 cos C plus D by 2, Z plus X minus Y plus Y plus Z minus X, C plus D by 2, okay, 2 cos C plus D by 2, sin C minus D by 2, that is nothing but Z plus X minus Y minus y minus z plus x whole by 2. This is equal to, you have here now sin c minus sin d. This is nothing but now 2 cos c plus d by 2. That is nothing but x plus y minus z plus x minus y by 2. 2 cos c plus d by 2 sin c minus d by 2. Sin c minus d by 2. That means x plus y minus z minus x plus y by 2, like this, right? Fine. This is what we have got. Just we applied sin c minus sin d formula. Now let us see, my dear students, here 2 cos of z, here anything will cancel. Let us observe here, 1 x, 1 minus x will cancel, minus y plus y will cancel. 2z by 2, that is nothing but z, 2 cos z, and sine of what you have here, right? Here anything possibility of cancelling, let us observe here, plus z and minus z will cancel, and we are having here 2x minus 2y by 2, that is nothing but x minus y. Wonderful. This is equal to 2 cos of, right, my dear students, 2 cos of, right, plus y and minus y will be cancelled, and minus z and plus z will be cancelled, and 2x by 2, that is nothing but x, right? And this is now sine of, right, my dear students, here plus x and minus x will be cancelled, and you are having here 2y minus 2z by 2, that is nothing but y minus z. Such a wonderful equation we have got, my dear student. Just observe now, this is 2 cos z into, this is sin x minus y, that is nothing but sin x cos y minus cos x sin y minus cos x sin y, like this. This is equal to 2 cos x into sin y cos z minus cos y sin z, like this, cos y sin z. Now this is nothing but what we have here, this 2 will cancel both sides. Let us have here something like sin x. Here what we are having is here, wonderful. Now see, my dear students, sin x into cos y cos z minus cos x into sin y into cos z, like this. This is equal to, right, here this is what, cos x sin y cos z minus cos x cos y sin z, right? This is what we have got, my dear students. Okay, wonderful. Once you got this thing, my dear students, what we do is we divide throughout by cos x cos y cos z, dividing everything, this one divided by cos x cos y cos z. And this is possible, we are dividing by cos x cos y cos z throughout both the sides, left hand side and right hand side, both the sides we divide it by cos x cos y cos z, like this, cos y cos z, right, my dear students. Now once we simplify this, what will be here, cos z will cancel, cos y will cancel, we will have here now tan x, wonderfully, we will get tan x here, and this term we are going to get cos x cos z will cancel, okay, minus what you are going to get, tan y, right? Wonderful. Tan x minus tan y is equal to, and here also if once you cancel cos x will cancel, cos z will cancel, then you will have here tan y, like this, tan y minus, right, cos x cos y, then you will have tan z like this. Wonderful. Okay, tan x minus tan y is equal to tan y minus tan z. Even I can write here, if I take minus sign common, my dear students, we are going to write tan y minus tan x is equal to minus sign, if I take common here, tan z minus tan y like this. Tan z minus tan y. This minus minus will cancel. Now this is something like, see, second term minus first term is equal to the third term minus second term. That means what we are going to have, my dear students, here, tan x comma tan y comma tan z are in arithmetic progression. Okay. Once we see here how beautifully we have got this particular problem, right? Okay, tan x, tan y, tan z are in arithmetic progression, right? In this way, we will do this nice problem, right? Please observe. Now see, my dear students, beautiful problem. The fourth one what we are having here is, if tan x plus alpha by a equal to tan x plus beta by b equal to tan x plus gamma by c, then prove that a plus b by a minus b into sine square alpha minus beta plus b plus c by b minus c into sine square beta minus gamma plus c plus a by c minus a into sine square gamma minus alpha is equal to 0, right? How we are going to do? Let us take, my dear students, here tan of x plus alpha. Okay, tan of x plus alpha by, okay, we have here tan of x plus alpha by a is equal to tan of x plus beta by b, like this, right? From this, what we will be getting? A by b. A by b is equal to, we are going to get a by b equal to tan of x plus alpha, tan of x plus alpha by tan of x plus beta, like this, right? A by b equal to tan of x plus alpha by tan of x plus beta. Now apply componendo dividendo method. You see, my dear students, a plus b by a minus b, componendo dividendo method, that is equal to tan of x plus alpha plus tan of x plus beta, tan of x plus beta, this whole thing divided by tan of x plus alpha minus tan of x plus beta, like this. A plus b by a minus b is equal to this thing what we are going to get, like this. And we know in the mathematics, my dear students, one result actually tan a plus tan b, tan a plus tan b by tan a minus tan b, by tan a minus tan b, like this. Tan a plus tan b by tan a minus tan b is equal to sine of a plus b by sine of a minus b, sine of a plus b by sine of a minus b, right? This is the result. You can prove also, right? You just take sin a plus b, sin a minus b, divide throughout by cos a cos b, you will get this formula, right? Divide throughout numerator and denominator by cos a cos b, you will get this particular formula, right? Wonderful. Now using this, you see, my dear students, what we are going to do is, once we have got tan a plus tan b by, okay, that is nothing but what I told you, right? Tan a plus tan b by tan a minus tan b, that is equal to, now only I told you that this is equal to sin a plus b by sin a minus b. Sin a plus b means what you are going to get? 2x plus alpha plus beta. Sin a plus b by sin a minus b, okay, that is nothing but, right, what we are going to get? Sin of alpha minus beta, sin of x plus alpha minus, that is nothing but sin of alpha minus beta, like this. A plus b by a minus b is equal to sin of 2x plus alpha plus beta by sin of alpha minus beta, like this, right? Once you have got this thing like this, okay, now what we do is, let us multiply and divide by sin of alpha minus beta here. Sin of alpha minus beta by sin of alpha minus beta, like this, right? Fine. This is nothing but, now what we have here, a plus b by a minus b into sine square alpha minus beta, sine square alpha minus beta. This is equal to, right, sine 2x plus alpha plus beta into sine of alpha minus beta, like sine of alpha minus beta. right? This is what we have got here like this. Once we got this, just multiply and divide by 2 like this. You just multiply and divide by 2, right? Now you have 1 by 2 of it. This is something like 2 sin A sin B formula. 2 sin A sin B, you know, my dear students, that is cos A minus B minus cos A plus B, right? That is nothing but cos A minus B minus cos A plus B. Once if you apply that, you are going to get cos A minus B. Here 2x plus alpha plus beta, right? You are going to have 2x plus alpha plus beta cos A minus B minus alpha plus beta like this, right? Cos A minus B minus cos A plus B like this. Cos A plus B means you are going to get 2x plus 2 alpha, right? 2x plus 2 alpha. You are going to get 2x plus 2 alpha like this, right? Wonderful. Here you see plus alpha minus alpha will be cancelled, right? And you have got this result is nothing but, my dear students, what we are going to get out of this is A plus B by A minus B into sine square alpha minus beta. This is equal to, right, 1 by 2 into, right, cos 2x plus 2 beta, cos 2x plus 2 beta minus cos 2x plus 2 alpha like this, right? Fine. This is what we have got wonderfully. Let us call it as equation number 1 like this. A plus B by A minus B into sine square alpha minus beta we have got like this. See the procedure, how we have followed the thing, just like this, our usual steps. Now see, my dear students, next similarly I think we will get the same thing like this. Just we write these things. Similarly, no need to do the procedure. Similarly, you are going to get, my dear students, what you are going to get is B plus C by B minus C. See here, B plus C by B minus C into sine square beta minus gamma. Sine square beta minus gamma, right? That of course you are going to get the same thing, cos 2x 1 by 2 into cos of, right? Here you have got 2x plus 2 beta. You are going to get, of course, beta minus gamma means you are going to get that as 2x plus 2 gamma, 2x plus 2 gamma minus, right, cos of, right? You see, my dear students, what you are going to get, right, B plus C by B minus C minus cos 2x plus 2 beta, cos 2x plus 2 beta like this, right? And similarly, you have here C plus A by C minus A into sine square gamma minus alpha like this. This is equal to 1 by 2 into cos of, right? Here we have got 2x plus 2 beta. This is 2x plus 2 gamma, and that you are going to get cos 2x plus 2 alpha. 2x plus 2 alpha, right? This is 2x plus 2 alpha minus cos of 2x plus 2 gamma like this. Wonderful. Now we just add them. This is equation number 1, this is 2, and this is 3. If you add them, this plus this, all the left hand sides if you add, this is what we require to add actually. If you add them, this 1 by 2 into, I think let us see that what we will have, minus this and plus this. Okay, and a plus of minus this, plus minus here, this total thing will cancel and you got equal to 0. Therefore, you see, my dear students, what you have got, this total is 0. Which one is 0? The left hand side part is totally equal to 0. That is what we require to prove. See how nicely we have got this particular problem. Now see, my dear students, this particular problem, the fifth one what we are having, the last problem of this class. Prove that cos 6x plus 6 cos 4x plus 15 cos 2x plus 10 is equal by cos 5x plus 5 cos 3x plus 10 cos x is equal to 2 cos x. This is what we have to prove it as 2 cos x like this. Now see, my dear students, how we are going to do this beautiful problem. Let us take here cos 6x plus, right, this numerator I am taking here, this is cos 6x. I am going to write 6 cos 4x as cos 4x plus 5 cos 4x, 5 cos 4x plus 5 cos 2x, 5 cos 2x plus 10 cos 2x 10 cos 2x plus 10 you are having. That 10 into cos 0x I will write this. Because cos 0 is 1, like that I am going to rest. We have grouped the things like this. This is one group, 5 as one group, 10 things as one group like this. Now you apply cos c plus cos d. This is now 2 cos c plus d by 2. Cos c minus d by 2. 2 cos c plus d by 2 is 10x by 2. That is now cos 5x. Cos c plus d by 2, cos c minus d by 2. That is cos x like this. Plus 5 if you take common here, once again cos c plus cos d. 2 cos c plus d by 2. 4x plus 2x by 2. That is 3x. 2 cos 3x cos 4x minus 2x by 2 cos x like this. Plus 10 we are having here. Cos 2x plus cos 0x. 2 cos c plus d by 2. 2 cos c plus d by 2 means cos x. Cos c minus d by 2 is cos x like this. Wonderful. Like see my dear students, here now I can take 2 cos x common in this all, like 2 cos x if I take common, 2 cos x if I take common, what I am going to get? Cos 5x. 2 cos x if I take common here, what I am going to get? 5 cos 3x. Wonderful. 5 cos 3x plus 10 cos x. This is equal to actually, right my dear students? Actually what we have taken, this is equal to, we got actually our thing, we have taken cos 6x plus 6 cos 4x plus 15 cos 2x plus 10 like this. Therefore you see my dear students how beautifully this equation reduces to, now if you subject 2 cos x, that is equal to cos 6x plus 6 cos 4x plus 15 cos 2x plus 10 by cos 5x plus 5 cos 3x plus 10 cos x. That is what we require to prove. See how beautifully we got this problem, right? A simple technique and such a beautiful way we have got this problem. Thank you very much students. So please practice the problems from your worksheet and also from your material what I have given from volume 2. The syllabus for coming IIT JEE mains is your total trigonometric ratios, compound angles, periodicity, extreme values and multiple submultiple angles, transformations. This total chapter will be including. Thank you. Please practice the problems from material and worksheet what I have given to you. Thank you very much.